Hello, everyone. My name is Adam Štěpánek. I'm a visiting PhD student, currently starting my third year from Masaryk University in Brno, Czech Republic. And I'll briefly talk about the topic of my PhD, which is playful software visualization, and especially a tool that I've built over the past couple of years and the lessons that I've learned from it. But first thing first, where exactly is Brno? Brno is about 800 kilometers away from here, which is about one Austria away. And if you went in that general direction for about 10 days without break, you might get there. It's a city that has a wonderful castle and a cathedral and also a lot of sculptures. And compared to Prague, it has a lot more up-to-date astronomical clock. I work in a group called Visit Lab, which, as the name suggests, deals in visualization. Historically, we've done a lot of molecular visualization and biovis, both in 2D and in 3D and in virtual reality, and as 3D printed tangible artifacts for education. But in the last couple of years, we've sort of diversified into other topics as well. So I have a colleague that is doing a visualizer for explainable pathology. I have another colleague who's done a visualization of snow levels in the Antarctic. And also the same colleague has done a visualization of patrolling games from game theory for our resident experts on the topic. My topic is, as I said earlier, playful software visualization, which I define as such a software visualization that uses aesthetic visual elements and features that entice play to be engaging or maybe even entertaining. Why that might be useful? There's a couple of reasons. The first one is that playfulness has been linked to open-mindedness and curiosity and creativity and the ability to find novel solutions, all of which are traits that you can imagine we might want from a software engineer. There's another reason, which is that programming, although it can be an enjoyable activity, can also be boring at times. And so including aspects of games can make it a bit more interesting and engaging. I would like to also now draw a distinction between playfulness and gamification. The reason why I use the term playfulness and not gamification is that I'm not all that interested in exploring the area of building entire games for software engineering tasks, but just using a couple of features and visual elements here and there to make it a little bit more engaging. There's also some reasons why not make playful visualization, which is that if those visual elements are used inconsiderably, they can lead to chart junk, which makes the visualization a lot less readable. So to summarize my research question, I'm interested in finding concrete visual elements and other elements that can make a software visualization playful and more engaging, while preserving its readability to the best of my ability. There's been a lot of research in this direction because I didn't discover America with this topic. There's been research both in gamification, and also there's been plenty of software visualization tools that include static elements such as textures, aesthetic looking meshes, mesmerizing animations, or outright using games for well, visualization and gamification. But what have I done so far? The story I want to tell of the Helveg tool began in 2020, when I had to decide what I was going to do for my bachelor thesis. I realized I could do basically two things well. I knew low-level graphics APIs, and I knew the C# compiler API. So I decided to combine those, and the result was the first iteration of Helveg, in which I visualize a C# project as an voxel-based island with structures that cover it, and those structures represent types found in the C# project. So for instance, this conifer over here is a C# class. This cabin is a C# struct. Those cargo containers of the shore are external dependencies, and so on. And from this visualization, you can see that the project has a certain size. It has a certain distribution of different kinds of types. In C#, it's fairly uncommon to see value types, meaning structs, and this project has a couple of them, which is fairly uncommon, but that's about it. You can't really tell how those types are related, what dependencies there are between them, anything of the sort. One thing that you can tell, though, is whether or not there are compiler errors, because the C# compiler lets me mine them very easily. So I decided that when I detect a compiler error, I set the corresponding structure on fire. One notable thing I want to point out is that when I began work on this prototype, I had no idea software visualization as a field existed. I only learned when I started actually writing the thesis, which was very late indeed. So the first lesson I learned is that it's good to check for existing work before implementing your own, because had I known that Code City and Islandvis, for instance, existed, I would have made a lot of things differently. And another lesson is that it takes a lot more than cool visuals to make visualization readable, because when I think back on the island I showed earlier, it doesn't really tell you all that much. It doesn't tell you anything more that you could tell just by looking at the icons in Visual Studio. So then for my master's, I studied computer games development. And 2 years later, I was in the exact same situation. And I thought to myself, okay, I could work on anything game design related. But in the back of my head, I thought, oh, that Helveg thing, that was actually kind of cool. I wish it had worked. And so I decided to do it all over again. But this time, I first conducted a user requirement survey. I wanted to know what programmers actually wanted from such a tool. So I asked 15 participants who were a mixture of student developers and teachers. Some of them were 2 of these things, a couple of them were all 3. And I asked them questions such as, what do you program and what would you like to visualize? And what tool format do you prefer? Like, should it be an IDE extension or should it be a standalone tool or a web-based thing? And what do you think of Helveg, the first iteration of it? And are there any other features you would like? And I learned a couple of things. First of all, I learned that even those programmers that in the beginning of the interview were crazy adamant that they don't need visualization for anything, by the end of the interview, they found always some sort of niche use case where it would have been very useful to them indeed. I also learned that they prefer web applications and IDE extensions over standalone executables because they are sort of afraid of viruses, and more importantly, it takes a lot more effort to install a standalone tool than to install an IDE extension. However, I also learned that they prefer tools, web-based tools that they can self-host, especially in work environment, because usually they don't have the permission to share company data outside of their network. Also, I learned that programmers want practical tools, and I don't mean just that it should be a tool that addresses a specific need, but also that, for example, when I talked to some of the participants of the study, and they saw that the original Helveg was a 3-dimensional tool, they told me, but my work computer doesn't have a dedicated GPU. Unless it's actually optimized, I won't be able to run it at all. But on the bright side, quite literally, I learned that programmers like to see their code burn because the fire shader was the most well-received aspect of the first visualization. So then in 2023, I implemented a new prototype. That prototype became my master thesis and also a first paper. The first paper I wrote during my PhD, which I presented last year at VisSoft. And this time there were a couple of differences. It was still a visualization of a C# code base, but this time it was a 2D node link diagram. It was web-based. It was self-contained, meaning there was a command line interface that produced a single HTML file, and there was no server involved in it at all. Which also made it automation friendly because it was trivial to run this command line tool in a continuous integration pipeline. So effectively, no user would have to install the tool at all if it were a part of this pipeline. And I also tried to make it as extensible as possible. I open sourced the C# API and also published it on NuGet so that if anyone wants to use the data miner and do a visualization for the hyper-specific use case, they can use my work. It looks like this. In the middle, there's the diagram itself. For instance, this node is a Visual Studio solution. These C# ones are the project. The yellowish and bluish ones are types. And you can zoom and pan and move, and you can collapse and expand nodes. And you can also filter them by name, by regular expression, and importantly, and most flexibly, by a JavaScript expression. About the type nodes, they are glyphs with multiple outlines. In the middle, there's an icon that I took from Visual Studio because most of .NET developers, C# programmers, rely on Visual Studio. So I thought using these icons would mean that they would be already familiar with the concept. Then there's the staticness outline, which presents the presence of the static modifier. So this class is static, that struct is not. Then there's the instance member outline, the width of which symbolizes the number of instance members tied to each instance of that type, and the same for the static member outline. The idea behind this design was that the static modifier is really the closest thing to the type itself, so it should be central, while the static members in C# are a part of the class, but essentially in name only, because they are effectively global variables, which you otherwise cannot have free floating in C#. And I also used the fire effect again and extended it to also cover warnings where the effect is a little narrower, it's only black and white, and it's just a little slower. I evaluated it through a qualitative user study with 5 professional programmers, and I asked them open-ended questions and also questions on the Likert scale, which I summarize very simplistically. Overall, they like the general appearance and what they can read from the visualization. However, they were either neutral or disliked the interactivity and the user experience. There was a couple of factors in this. For one, the only tutorialization in the prototype was a short description in a panel, which when I saw them use the tool, nobody ever read. They disliked also the control scheme because there were no shortcuts. And they also disliked the JavaScript filtering feature. However, they still felt that for use in automatically generated API references, it could be quite handy. I also gave them a test because I wanted to know just how accurate are C# programmers that use the Visual Studio IDE in determining what each of these icons meant. And I thought they would do a great deal better than mere not even 70%. Because it turned out that, okay, they were familiar with these icons, but when it came to actually assigning their meaning, most of them were struggling quite a bit. And also the glyph outlines, when I gave them a test and asked them to compare them and tell me which one has the most static members and so on, also did quite poorly. However, on the upside, all of them really liked the animated effects once again. So another lesson that I learned from this second iteration is that interactive graphs can be an effective method for navigating API references. I also learned that programmers don't remember the exact meanings of icons from their IDEs, And some of these programmers used the IDE for 12 years. And turns out I'm the weird one for remembering what the icons actually mean. I also learned that C# programmers actually really hate writing JavaScript, especially if it's the most flexible filtering feature there is. It influenced a lot of the feedback that I got. And once again, I validated that programmers really like to see their code burn. You may have noticed that the second iteration of Helveg was a lot less playful than the first one. So I decided to compensate for that by including an overlay which turned the noding diagram into a strangely shaped pizza. And it preserves some of the readability. You can still tell that there's a structure, a hierarchical one, but it also makes it less readable, because now the viewer has to remember that what does a piece of bacon mean? What does a piece of chicken mean? And I asked the participants what they thought of it, and they found it funny, and they said that they would share it with their colleagues. So the lesson I learned from this experiment is that a pizza-based visualization works at least as a one-time joke. The paper that I mentioned and presented last year at Vissoft somehow won the Best Paper Award. And we got to write a journal extension in which we tried to fix most of the issues we found. So this is the original version. And we introduced a new panel on the left, which is toggleable, which is the more traditional view of the hierarchy of the code base that you would typically find in an API reference. So that now there are multiple views that the user can cross-check. We also focused a lot on the diagram itself. We added a couple of new color schemes. We completely changed the control scheme, added keyboard shortcuts, mouse movements. If you click on this button, you see a wonderful cheat sheet. There's now an interactive tutorial. There are hints on every button and every option. And we also focused on the panels on the right as well. For instance, when you select a node, you can now see a preview of the node. You can see what the declaration looks like in code. This comment over here is data mined from the code, and the details are all provided by the C# compiler. I also made a custom set of icons, which allowed me, they are still heavily inspired by the Visual Studio icons, but it allowed me to fix some of the ambiguities. It allowed me to do a couple more controls, a couple more color schemes. It also allowed me to ditch the staticness outline in favor of icon styles. So for example, the class icon is still the same, but now the static versions of them are filled. And it also allowed me to add new icons for concepts which were not represented before. So, and that's why I also try to introduce some playfulness in that. Because when you look at the method icon, it's this circle box. And when you look at constructor and destructor and operator, the constructor has this little shine from it because the thing is completely new. The destructor falls apart because it's the last thing that an object ever sees. And operator has, well, operators on it. And it's also filled because operators in C# are always static. Interestingly, the record class and record struct icons, which I created, were somewhat controversial. They are meant to represent vinyl records, and some of the participants got it and felt that it was quite cute, and some of them thought that, okay, that's a little strange. I don't really get that. We also completely ditched the concept of the outlines and replaced it with a much more common donut chart, which ended up being a lot more intuitive. And we also introduced a completely new filtering mechanism, which is this filter builder component, which you can be familiar with from various e-commerce sites. You pick a property to filter by and an operator and a value to compare against, and you can stack as many of these as you like. So now the C# programmers don't actually have to write JavaScript expressions unless they want to use something really strange. So then I conducted a comparative study with the same 5 programmers as before. and it actually improved a lot in terms of user experience and all those scores that were low before. So I learned that programmers are also users and they care about the user experience, even if you explicitly tell them that it's a research proof of concept prototype. They will still complain that the thing is user unfriendly. I also learned to forgo some esoteric design ideas that make sense in my head in favor of things that are actually commonly used and therefore intuitive. I'm referring to the outlines versus the donut chart. Sorry. However, some issues still remain. The layout is computed using a force-directed iterative layout algorithm, which when it runs in the browser on a large code base means that it takes a lot of time to converge to anything meaningful. So the tool still doesn't scale well, meaning that for large code bases where it actually would have been useful, it's quite unusable. And the last lesson that I want to impart is that making tools for developers is just bloody difficult, because not only does it have to be readable and engaging and user-friendly, and it has to run in a browser on an IDE, but there's also the other half of the whole tool, which is data mining, that I almost didn't talk about at all, which turns out depends on the language tooling. And despite C# having lovely language tooling, it's still quite volatile. For example, every year, Microsoft releases a new version of .NET. Actually, it will happen in about 3 weeks. And every single year, they find a brand new way that completely breaks Helveg. And then I have to fix it. And that's also the reason why Helveg doesn't support any other languages, because I don't have the time to fix it for all of them whenever they get updated. So to summarize all of this, I would recommend to focus on making a visualization readable first, and then try to add playful features in it, and only in moderation. Because when I look back to the three-dimensional first iteration of Helveg and Code Pizza, I see that I went a little too far. I would also recommend to use familiar visual elements that are familiar to the target audience, such as the Visual Studio icons to C# programmers, but only as a basis for your own custom elements. Also to favor common designs over esoteric ideas. That's again a throwback for the type glyphs and the outlines. And finally, that user experience and user interface matters even for research prototypes, especially if they are interactive tools. So when I look back to the question I posed in the beginning of what elements are nice to make a playful software visualization and don't harm its readability, so far the answer is I don't actually know. I don't have a concise answer, which makes sense. There's still 2 or 3 years left in my PhD. But so far it seems that it's probably fine, but that more research is needed. Okay, I've been here for 5 weeks, so you may also wonder what I've been doing all this time. So with Marco and Michele, we worked on a new tool which visualizes artifacts on GitHub, meaning issues, pull requests, and discussions, as a landscape with trees and islands and ocean, which looks a little familiar now that I look at it. But this time it's a bit more readable, I hope, because you can see in this that, for instance, in August of 2016, the JTML repository was filled with issues, these conifer trees, and a couple of pull requests. Each of these islands represents a topic of discussion in it, which we extracted using topic modeling and machine learning techniques. And also there's a slidable time window. So if we move forward 20 months, we can see that a lot of the discussion actually quieted down. And now there's just a couple of trees in a couple of islands. So if you are interested in Helveg, you can install it with this single command if you have .NET already installed, or you can look in the Git repository. If you want to reach out to me, this is my handle on Discord. This is my email address. thank you for your attention.